I guess we'll just start off with what you've done already, right? So like, we're gonna slowly work through everything. This was kind of like our hello worlds, which is like the initiation to like any basic coding thing is like a hello world. So what you've done here is the println is like a function. So like a lot of coding is made up of these functions, right? And it's essentially this chunk of code that tells the computer to do something. And then what we're going to use a lot of is the parentheses. So the parentheses kind of group the things that we tell the functions to do. And then the semicolon tells it that's the end of everything that I'm telling you. So in some coding languages...
Okay, so it's like a full stop kind of.
Yeah, exactly. It's like a full stop. So parentheses are like a full stop. First, go into just like data types and kind of understanding what a data type is and how it works in the computer. So as you probably know, or what you've probably heard before, is like computers are pretty much made up of ones and zeros, but you probably don't really know how it's made up of ones and zeros.
It's just gibberish.
Yeah,
no idea.
Yeah. So what we're gonna do is we're going to delete everything that you've got right now.
Yay! All right, let's go.
And we're gonna type int, like int. So this is telling the computer that we want to keep a number stored in memory. And then we're gonna space. We're gonna give it a name, so we can call it whatever we like. We can call it test. We can call it A. We can call it number 1000. So you can just call it whatever you like. Just letter A if you'd like.
Okay.
And if you hit space again, you can then go enter.
Wrong.
Enter, sorry. Not enter. Equals. Oh god.
Equals.
I'm gonna say the wrong words like a million times. I know what I mean in my brain, but I'm gonna
You're also gonna you're gonna say the right thing too, and I'm gonna hit the wrong symbol. I imagine that's gonna happen a lot.
Yeah. And then we're gonna give it a number. So you could make it like number 2, number 10, number 69, whatever you'd like.
No space there, just a number.
Yeah. So it doesn't need the space. And then semicolon at the end. So what we've done, we're putting in this code. So what we can then do is underneath that, you can then type out println again.
Wait, println like that?
Yeah, so println means print on a new line, where print just means print. And then if you use the brackets again, but instead of using the quotation marks, just put the letter A.
Okay.
Yeah. And then press play. And it returns number 69. So the computers save the number, and then you can use it multiple times throughout your code. So how it stores it, so if we change it to the number 1, before the A, like just before the A, after the parentheses and before the A, we're gonna type binary, binary, and then put brackets around the A.
Excellent.
Okay. Like another one.
Yes. Yep. And then if you hit play. So this is how the number is actually stored on the computer. That's
binary code, is it? Or
each 0 and 1 is a bit. And computers are essentially just made up of zeros and ones. So if you now change it to a 2, and then hit play again, it will go up to it would show you what the 2 represents. And this is kind of how all the data on your computer and how everything ever happens on your computer is through binary. And what you can also do is, instead of a 2, you can type in all caps, max_int. All caps, int as well.
Oh, sorry. Yeah. Oh, it went purple!
Yeah, so this is the biggest number in binary that we can store on it. So if we get rid of the binary now, we can have a look at what that number is. Yeah.
Like just remove that?
Yeah, and remove the brackets as well.
Oh, okay, sorry.
That works as well. An int is always a whole number as well. So it can't be a fraction or like a partial number. It's a whole number. It's 1, 2, 3. It's not half. But there is things that you can define on the computer that are partial numbers, and they're called floats. So if we change the int to the word float, the int before the A.
This one, yes.
Yeah.
To float?
Yes. Yeah. And then we can set that number to whatever you like, 0.01, or anything like that. So you could change max int to like 0.01, and then it should just work. Another cool thing to know is char. So instead of float, we're going to change it to char.
CHAR? Yeah.
Yes. So chars are characters on the computer. So your computer essentially has this map of what a certain binary code represents as like a letter. So you can, if chars are represented by single quotes and then a single letter. So if you change it to single quote,
Wait, you
Yeah.
mean the quotation marks?
yeah. So delete the
Just-
0.
just-
Yeah,
just-
yes, like that. Perfect.
Just the single one.
Yep.
Okay.
So now.
There and there.
Yep. So
Okay.
now you need to delete everything inside of it and just make it a single letter.
Single letter.
Yeah. So just like an A, B. Yeah. Perfect. Yeah. So
Alright.
so that's the binary code that represents the letter A to the code. So if we changed it to B, it would go up by 1. See, the way that binary works, this is probably going a bit beyond some basic stuff, but it's the power of 2. So the very first one on the far right represents 1 or 0. So if there's a 1 there, it represents the number 1. And then the one next to it represents 2 or 0. So if there's a 1 there, it means there's 2. So if it's 1, 1, then it's 3. That's a bit beyond, but
Okay.
all you need to know is that characters are a bit of information that's stored
In the ball.
Yeah. Okay.
So beyond that, there's these things called strings, and strings are essentially a collection of characters. So if we change char to string, yep, and now capital S.
Capital S.
Yes.
Sweet.
Yep.
Okay.
And then instead of single quotation, it's a double quotation. And then
Sweet.
you need to put the equals again.
Oh, the equals. Wait, what?
Before
Here?
the A, after the A and before the B.
Oh,
Yeah,
okay.
so essentially, the way you read it is that you're making it equals. It literally means equals. So you're saying that A equals to the thing on the other side.
Should there be spaces here or no?
It actually doesn't matter. The spaces are just there for our sake to read it and whatnot. A string is made up of a collection of characters. So you could make it like save the bees or like whatever you'd like. It's a whole string, so you can make it just more than one bee.
Oh, so you can like just say anything.
You could put anything in there. You can make it a whole sentence. You can make it a paragraph. Like, yeah. Pug. Yeah.
I'm very creative.
Yeah. And that won't work because the binary of A, because a string doesn't have a single set binary. It's a collection of them.
Okay.
So you just need to get rid of the binary and it will print out pog.
Just remove the word binary.
Yeah. And it should say pog.
Pog. Let's go.
Pog. Yeah, cool.
Honestly, I was gonna like put something like weird or like, and I was like, no, let's just
Yeah,
let's not be too weird yet. We just met.
Yeah, no, it's soon enough. But yeah, those are pretty much the main things that you need to know. There is one extra one, and it's an array. So similar to how a string is like a collection of characters, you can also have a collection of different numbers. So if you change string to int, and then put square brackets after.
Square brackets after the word int.
Yes.
These motherfuckers, right? All right. Wait, what am I putting in brackets though?
Nothing. It's just an empty.
Nothing. Just
yes.
Okay.
Yeah. So this is telling the computer that we're defining an array of ints. So then instead of after the equals, instead we're gonna do curly brackets.
After the equals.
Yes. Yeah.
Curly brackets.
Yes.
Wait, are these the curly brackets?
And then we're just gonna do 3 random numbers. Yep. Perfect. And then you have to close it off again. Yep. Perfect. And you can delete all the other strings.
Like that stuff. Goodbye, Pog. All right.
Now if you print that, it should be all 3 of your numbers. And as you can see here, yeah,
that's cool.
And as you can see here, it's stored them in 3 different locations as well. So you can access an array and tell it, I want the first number in this array or the second number in this array. But one thing to keep note as well is that it starts from 0. So the first number is 0, and the second number is 1, and the third number is 2. But those are the main data types that you kind of need to do. What you can actually do is after the A, you can put a square bracket.
Here?
No, the print A.
The print A. Sorry. Yep.
And then put a square bracket. Yep. And then put number 1. And then another square bracket.
Yep.
And then print play. And so we're telling it, I want you to print the one that is stored at number 1 and just that one.
Okay. Oh, okay.
So we can access that number at any given time. So we can store them together and we can do all this stuff, which is kind of cool. But yeah, so those are the main types of ways that data is stored in the computer. Now what we're gonna do is we'll just clear this again.
All of this?
So what you can do, you can hit Control A.
All right. Select it all, then delete.
Yeah.
Yeah. Sweet.
Dead.
So what we're gonna do is we want to make 3 ints with 3 different names, with all the same value. Define a int variable. You got to type out int, the name you want to save it as, and then the number that we're saving it as. You can literally call it whatever. You could call it Pog. You could call it Weird Champ. You could call it whatever you like.
Can we swear?
Yeah, go for it.
Yeah. All right.
What's your favorite curse word? Oh fuck.
Probably fuck. Oh. Alright, awesome.
And just set it to like number whatever, number 69, number 5, number 420, number 42.
Okay, 420 sounds good.
You need the equals though.
Equals in between them?
Mm-hmm. So you can think of equals the same way as you do in maths. So it literally just means set it to this. This is this.
Okay, cool.
What's on one side is equal to what's on the other side.
Mm-hmm.
Yeah, and then your semicolon. Yep, cool.
Alright.
So we want to make 3 of those, but all with different names.
Okay.
You got this.
Oh no.
You failed!
Is this a bad time to say that I did not do well in math in high school?